number one, find the standard equation of the circle with center. I know the standard equation of a circle. It's x minus something squared plus y minus something squared equals radius squared. The radius is 39. The x coordinate is negative 38. The y coordinate is 14. Done. Okay, 15 seconds. Next. No questions on that, I hope. Next, find the slope-intercept form of the line that passes through A parallel to the line segment BC. Jesus Christ. Okay. Slope-intercept form is going to be y equals mx plus b. Where are these things? I got to draw a picture. A is at 1, 1. A. B is at 2, negative 3. B. C is at negative 2, negative 1. C. All right. Now, parallel to the line segment BC means it has the same slope. So what's the slope of BC? The rise, let's say I'm going this way. So the rise from C to B, C is at negative 1, B is at negative 3. So the rise is negative 2. So here's the slope is negative 2. And the run from C to B, B is at, so I did negative 1 minus negative 3. Sorry, let me write this out a little bit more precisely. Minus negative 1. So that's this at y coordinate minus that y coordinate divided by this x coordinate minus that x coordinate minus negative 2. So that is negative 3 plus 1 is negative 2 divided by 4. That's the slope of negative 1/2. That's the slope from C to B. The line passing through A, well, that's going to be, I didn't leave enough room for this one, obviously. So let's continue problem 2 over here. It's going, I'll put it first in point slope form. So I want the point 1, 1. That's the point 1, 1. So y minus 1 is equal to negative 1/2 times x minus 1. And I can put that in point slope form, y equals negative 1/2 x. And then what? I have a positive 1/2 plus 1. So I guess it's plus 3/2. I hope you guys are checking that I'm right. And that looks roughly right, because if I think about the line parallel to that, that's going to go a little higher than wherever A was. Good. Next. So that burned a minute. That took some time. B. Find an equation of a line through B perpendicular to line segment C. Oh, come on, you're gonna make me do it again. CA. All right, CA. So what's the slope for CA? I'll do 1 minus negative 1. So that 1 is this 1 minus this negative 1. That's the numerator. The denominator is 1 minus negative 2. Everybody see what I'm doing? That's this 1 minus that negative 2. Okay. That is 2 over 3. So that's 2/3. That's the slope from C to A. The slope is 2/3. That seems about right. But I want the line perpendicular. So the slope of the perpendicular slope will be negative reciprocal. So negative 3/2. And it goes through the point B. So that's y minus negative 3 is equal to negative 3/2 x minus 2. And it wants the slope form. It didn't specify. Well, that's the equation of a line, but let's say it did want the slope intercept form. Y is equal to negative 3/2 x. So this was the answer for part A. Y equals negative 3/2 x, and I got a 3/2 times 2 is a 3 with a plus sign. That's a plus 3 plus 3 on this side goes to the other side minus 3, so it's 0. Yeah, that's what I'm getting too. So it's just this. This is the final answer. Y equals negative 3/2 x. And does that make sense? If I am perpendicular to here and I'm passing through B, yeah, that kind of makes sense for that to cross through 0. Okay. Too fast? About right? A little too fast, but it's being recorded so you can go over it. Will. Where is this? This file? I'm going to put, so there's a copy of this file in Canvas. But I'm going to put this very PDF online for you to review. Okay, so let's do these problems together now, and then we'll, and then you'll have a chance all weekend long and Monday to review. Next. The perpendicular slope through B. Yeah, so that's going to be like this. And that's perpendicular to CA. That's the right angle. Okay, next. We got a blah, blah, blah is a circle. Oh, it is? Doesn't look like a circle. Let's see. I got 5s everywhere. Let me get rid of those 5s. So first of all, I have x squared plus 60 divided by 5 is 12. That's a little better. I'm going to leave room here. I'll tell you why in a second. Y squared, you probably know why, plus 10y, and I'm going to leave a little bit more room, plus 25 equals 0. Is that right? All I did was divide everything by 5. Now I'm going to complete the square. So this is twice 6. So I'm going to add 36 here, and I'm going to add 36 here. This is twice 5. So I'm going to add, well, actually, I already have the 25. I don't have to add anything. I just have to group them. So this is the equation x plus 6 squared plus y plus 5 squared is equal to 6 squared. It's 36. So we're doing a little bit of arithmetic, but not anything that requires a calculator, right? You see that. So find the center and radius. Center, the center is -6 comma -5. The radius is 6. That's problem A. B, find an equation of the form x equals g of y to describe the, I can't read anymore until I draw a picture. X is -6, y is -5, and the circle is over here some. Okay, so what is it saying? Find an equation of the form, bless you, x equals g of y to describe the right semicircle. That's this. Oh, I see what he's saying. Okay, fine. So x is equal to. So if I solve for x, I take the 6 squared, I subtract y plus 5 squared, I take a square root, right? You see what I'm doing? I want to isolate x. So I'm going to move this to the other side. There's a square here, so I'll take a square root. That's what the square root is doing. And then do I want the plus square root or the minus square root? It said the right side, that's going to be plus. This is going to be the minus sign. So this is a plus. And then the -6 has to come over here. So that's the equation. You guys see that? -6 plus square root of 6 squared. So that's this. -6 plus the square root will give me that semicircle. Okay. Find an equation of the form to describe the bottom semicircle with the given equation. Okay, the bottom is going to be something very similar. Y equals, okay, I get the 6 squared minus x plus 6 squared, and I square root that. The bottom means I put a minus sign, and then it's centered at -5. So that's the last -5. Okay, find an equation to describe the top semicircle. You serious? Okay, plus or minus. Y equals -5 plus root 6 squared minus x plus 6 squared is the answer to this. Done. Next. Sorry? Did I hear something? No. Good. Let's go. Okay, solve for t in this equation. Oh, God. Okay, absolute value is 10. That means the thing is either itself actually 10, or the thing is either 10 or -10. That's the only way your absolute value is going to be 10. All right, that's easy. I subtract 1 and I divide by -2, so I get -9/2. And here I subtract 1, I get -11. Divide by -2, I get 11/2. Done. Next. All right, solve the inequality. Something is less than 4. To be less than 4, here's -4 and 4. To be less than 4, your absolute value is less than 4 if you're close to 0, right? So this means 1 plus 2x has to be less than 4, and 1 plus 2x has to be greater than -4. You got to be inside this region to solve that equation. Both of those things have to be true. Okay, so that means x is less than 3/2, and x is, I subtract 1, that's -5, it's at least -5/2. Express the answer in interval notation. Got it, that's -5/2 and 3/2. And do I want open brackets or closed brackets? This is a strict inequality, so I want open brackets. Done. 5 problems down. Next. Oh, solve this other inequality. All right, something's greater than 1. To be greater than 1, here's 1 and here's -1. Greater than 1 means you're farther away from 0 than 1 is. So that's two possible solutions. It's not an and, it's an or. Right? You could either be, you're either an absolute value greater than 1 because you really are greater than 1, or the other option is you're an absolute value greater than 1 because you're less than -1. That's it. Those are my two solutions. Those are my two equations. So 1 plus 3x either is greater than 1, or unlike the and that we had here, or 1 plus 3x is less than -1. Those are the two ways that can happen. So if I solve this, x is, let's see, the ones cancel, I divide by 3, so x is positive. Or if I move this 1, that's a -2, I divide by 3, that's still a positive number, x is less than -2/3. So in interval notation, what is that? It's minus infinity up to -2/3. Union, start at 0 and go out to to positive infinity. That's this answer. This is this answer. Good? Question? No. Yeah. Alan. Align. Yes. If the absolute value is greater than 1, what does that mean? That means I'm farther away from 0 than 1 is. So there's two possible ways that can happen. I can be greater than 1, or I can be less than -1. That's how I'm more than 1 away from 0. Okay, so make sure you guys remember. I don't remember these things. I just think about what it means. I always draw a picture. I don't know if I'm a visual learner or whatever. I always draw a picture, and then I don't have to think about, oh, less than is and greater than is or. No, I don't know that. I just draw a picture, and then I see which one's going to be and which one's going to be or. Let's go. Let's go. Oh God, theta is the angle defined by blah blah blah, where x is blah blah blah. Use the information. All right, theta is right here. That's theta. If the sine, so what is this really saying? It's saying that the sine of theta is supposed to be 23x. You have to be a little careful with inverse sine and sine, because inverse sine is only defined on some region. But let's just go with this for a second and see how much sense we can make of it. All right, so the sine, that means opposite. This is opposite over hypotenuse, right? Dyslexia. All right, opposite over hypotenuse. Hypotenuse is 1. This is 1, so that means the opposite is 23x. So A really is just nothing but 23x. And then I know the Pythagorean theorem, that's this squared plus this squared is going to give me 1. So B has to be the square root of 1 minus 23 squared. I don't think you have to know what 23 squared is off the top of your head. 529. Is that right? Whatever. I'm not asking. If you have a big number and you need to square it, just leave it 23 squared. I do not care that you can do arithmetic. All right. That's not the same as, you know, if you go from here to here and you get that wrong, come on. That's not the same thing as 29 squared, 23 squared, whatever. 23 squared, that's not 520. It is. Anybody? 529, right? Yeah, okay. All right, express A and B. Oh, look at that. We did part A without even trying. Okay, express A and B. Here's A in terms of x. Do not use trigonometric functions, right? Don't tell me it's the arc cos of this, of the arc sine of whatever. That's A, that's B. Done. Next. Express the area. Oh, come on. What's the area? It's 1/2 base times height. So it's 1/2 base 23x times the height, square root of 1 minus 23 squared x squared. Give exact values, do not round. I don't, how am I rounding? Oh, because 23 halves, I don't know, whatever. Express sine of 2 theta in terms of x. This one we know, sine of 2 theta is 2 sine of theta cosine of theta. That's 2 times, the sine of theta is 23x, and the cosine of theta is the square root of 1 minus 23 squared x squared. Good? Could you do these?
You simplify.
You can leave it like that. I don't care that you know the 23 times 2 is 46. That's not what I'm testing. Okay. Notice so far that none of this has been calculus. This is all chapter 1, which is pre-calc review. That's got to be solid and just right at your fingertips. So pretty soon we're going to get to calculus. All right. Let's do a timing check. We're on problem 8. We've spent 20 minutes. That's pretty good because there's 20 some problems here. We're making good time. Keep going. All right. I is 2 to 37. So here's 2 and 37. That's the interval, the closed interval. I got to draw it so that I can see it. Okay, find the length. Well, if it goes from 2 to 37, the length is 35. Okay, find the midpoint. All right, the midpoint. How do you find the midpoint? Well, their sum is 39, and 39 halves should be the midpoint. Or alternatively, if the total distance is 35, then I need 35 halves in each direction. And so 35 halves is somewhere here. So what do you want to say? 39 halves? Their average is 39 halves? Did I get that right? Hang on a second. Don't tell me. Okay, tell me. Yeah, that's right. Because then this distance, I have to take off 4 halves to get 35 halves. And this distance, again, 37, double 37 is 60, 74, 74 minus 39 is 35. So this is 35 halves in each direction. Okay, great. So the midpoint is 39 halves. Okay, recall that this is a mathematical way of writing yeah. For example, yada, yada. Find A and B so that you can express the interval as this. Are you kidding me? X minus the midpoint, 39 halves, has to be less than 35. Okay, so that's another way of writing this interval is you start at 39 halves and you go no farther than 35 away. That can't be right. That can't be right because it's too far. 35 is the whole distance. 5 over 2. 35 over 2. Okay, so half that distance is the radius of the interval, if you like, as opposed to 35, which is the diameter of the interval. Okay, again, anybody can make mistakes like this. So when you're done with the test, go back and check. Or even as you're doing it, I see the 39 and the 35, 39 halves and 35, and I'm thinking, wait a second, that means the endpoints are going to be at half integers, but the endpoints aren't at half integers, they're at integers. So I better have 39 halves and 35 halves. So something's wrong, right? My spidey sense went on. So this is the kind of thing I want you guys developing. Next. Too fast? Okay. Don't feel like you have to write everything. This is all going to get posted, right? So you can go over it again. Get into the experience of solving the problems together. Next. Next. Okay. Oh God, I hate these. Find the solution. All right. I have a sine times a cosine with the same thing inside. So that's a double angle formula, right? So this is 1/2 sine of x over 3. Because sine of x over 3 is twice sine times cosine of x over 6. Did I do that right? I think I did. So the formula that I know is sine of 2 theta, we used it already, is 2 cosine theta sine theta or sine theta cosine theta. So I have sine cosine, I need to double the angle and I need to halve. So I doubled the angle and I halved. Okay, good. So that means sine of x, so now our new equation, this implies sine of x over 3 is equal to, I can multiply both sides by 2. Okay, sine is a half. Sine is a half. I know the graph of sine of x. Let's solve sine of x. So here's sine, y equals sine, and we're in 0 to, there's some interval, we got to think about this. This one's going to take a little time. This one I have to do a little bit carefully, so that's one I'm going to invest time. All right, where is sine equal to a half? That's right here. I have to draw a 30, 60, 90 triangle for myself. If it's 1, 2, root 3, that's going to be the 30-degree angle because it's the smaller side. That's going to be the 60-degree angle. So that happens at pi over 6. So that's pi over 6. This is pi over 2. So that's going to be 5 pi over 6. So that's the kind of thing where this is going to happen, right? But it'll happen again. I don't care about negatives, but it'll happen again over here at what is this? 2 pi plus another, so that's 13 pi over 6, and another over here at I'm adding 12, so 17 pi over 6. You guys see that? I'm just giving myself a couple of values for sine. This is sine x, but we don't have sine x. We have sine x over 3. Okay, so that means that x over 3 needs to be something like pi over 6 or 5 pi over 6 or 13 pi over 6 or 17 pi over 6. There's a long list of possible values. I'm just going to write the first couple. What does this mean? What does this tell us? If I multiply both sides, that's x is pi over 2. Great, right? If I multiply them by 3, another option is 5 pi over 2. So far, so good. Another option is 13 pi over 2. How far do I have to go? I have to go all the way up to 12 pi. This is still 6.5 pi, so I got a ways to go. 17 pi over 2. Jesus Christ, how many are there going to be? 17 pi over 2 is getting kind of close to 12 pi. 12 pi is 24 pi over 2. I think I just have one more. Or is that the last one already? Let's see, I'm jumping by, sorry? Yeah, I think I have 22 pi over 2 left. This is jumping by 4. This is jumping by 8. This is jumping by 4. I'm going to jump by 8 to the next one. 17 plus 8 is 25 pi over 2, which is already more than 12 pi. So I'm done. These are the solutions. Okay? You could do this, right? Yep. Hard.
Yeah, I was wondering, would you recommend writing an equation for this? Would that also work?
Write an equation. Well, I did write an equation, but then how would I solve that equation?
It's like if I were to like say like x is equal to like x plus 2, like that all of them.
Oh, you can write an equation if you're more comfortable with it. You can say, yeah, okay, it's pi over 6. So in other words, you want to say something like x is equal to pi over 6 plus 2 pi, or 5 pi over 6 plus 2 pi times n for any integer n.
Yeah.
You can do that, and then you have one more variable to think about. So I would just write out I would just kind of guess what the first couple of values are likely to be, and then see how far I have to go until I get everything in the interval that's being requested. Another question?
Where did this cosine go?
Where did the cosine go? There's sine times cosine. Sine times cosine is too complicated. When you see sine times cosine, your spidey sense should be going off for the double angle formula. So the cosine got swallowed in the sine with twice the angle. Instead of a pi over 6, here I have a pi over 3. That's exactly, if you didn't think to do that, you'd be in trouble, because sine times cosine is a complicated function. Right? That's exactly the thing that's going to change the equation between, oh God, sine times cosine. I have to draw a graph of sine, I have to draw the graph of cosine, I have to think about what happens to their product. No. Know the double angle formula. Know the double angle formula, know it cold, and recognize it in practice so that you go, oh, wait a second, that's how you solve this. Okay, great question. We need that sine. We need that cosine to go away. Peter. The 1/4 turned into a half because there's a half. Sine of 2 theta is twice sine cosine. Here I have sine cosine. So I have half of the double angle formula. And that 1/2 with that 1/4, did I do this right? I think so. Yes. I multiply both sides by 2, just checking, and 2/4 is a half. I think that's right. Anybody else got the same thing? Okay, yeah, question? Oh no, you got the same thing. Great. Next. Not bad. That costs some time, but there's no way to rush that one. At least I don't have a way to rush. All right, f is equal to this with the domain. Got to draw a picture. So this is kind of easy. They gave us a factorization, x times x minus 12. That means it's going to go through x equals 0 and x equals 12 are the two places that it's going to go through the origin. And it's a positive x squared, so it's a nice happy parabola. You guys do happy parabolas and sad parabolas? I don't know, whatever. But the midpoint of this is x equals 6, because that's the midpoint between 0 and 12. And the domain is x is less than 6. So we only care about that part of the back half of the parabola. Okay, find a formula for f inverse. Now, in general, this would be hard, but well, it wouldn't be that hard. So in other words, instead of saying y is equal to this thing, which is x squared minus 12x, let's change the roles of x and y. The inverse function is the function that replaces the roles of x and y. So I'll say x is equal to y squared minus 12y. And now I want to solve this for y. Right? So I'll write y squared minus 12y minus x is equal to 0. And then I can use the quadratic formula. Y is equal to negative b, that's 12, plus or minus. Do I want the plus or the minus? I don't know yet. It's going to be the minus. I can tell already, but yeah, why do I know that it's going to be the minus? Because if I take this across the line y equals x, which is how you take the inverse function, I can sort of, well, here's the line y equals x. And if I mirror this across that line, let's make it, I don't know, green or something. I get a parabola, I get a sideways parabola that's going to go through 0 and 12 here. So I'll get a sideways parabola like this. And I want the bottom half of it. The bottom half, because I want the negative values here, as opposed to the positive values here. That these positive values are getting crossed off. So these positive values are going to get crossed off. You see that? How you would do that geometry? Now that's all just guessing. Let's see what's really going on. So that's why I think it's going to be a minus sign here. But all right, keep going. 12 plus or minus square root of b squared. It's 144. If you wrote 12 squared, you wouldn't lose a point. You would not lose a point for writing 12 squared there. Minus 4 times a, which is 1, times c, which is negative x, divided by 2a. A is 1. Right? Negative b plus or minus square root of b squared minus 4ac over 2a. You guys hopefully were drilled this into your core, into your teeth. Okay? Now, again, that's the formula. Now you have to think a little bit. Well, I want to make sure that the value 0, 0 is there. So is the value 0, 0 there? If I make x equal to 0, if I have a plus sign, then I have something positive, and I have something positive. So I do not want that plus sign. I want the minus sign. So that would be the general solution. And the solution, so a f inverse of x is 12 minus the square root of 144 plus 4x all over 2. Okay, does that make sense? What's the domain of f inverse? So that's b. What's the domain of f inverse? Well, that's the same thing as the range of f. The domain of f inverse will be the range of f. And so where does this negative 6? When x is negative 6, I have 6. Sorry, when x is 6, I have 6 times 6 minus 12. That's a negative 36. Negative 36. So this is the point 6 comma negative 36. That means on my inverse function, this is going to be the point negative 36 comma 6. And then it's going to go downhill from there. And so the range is the domain of f inverse. Domain of f inverse is going to be negative 36, including 36 itself, out to infinity. Okay, all of these values are available values for the inverse function. You guys could do this. If you said no, now you know what to practice. Do 10 problems like this. Ying. Why did I choose the negative instead of the plus minus? Yeah, so for example, I don't know which branch to take, this branch or that branch, right? But if I look at the original curve, so you can say, well, what about the point 0, 0? 0, 0 is on the original curve. That means when I reflect across the line y equals x, 0, 0 will still be on the inverse curve. So if I want this point to be on the curve, do I want the top curve or the bottom curve? That's one way to guess that you want the bottom curve, which is the one with the minus sign. Does that make sense? Because this point was on the original curve, it's still, this same point will also be on the inverse curve. But the inverse can't have, has to satisfy the vertical line test, which is why the domain is restricted. And so which half am I going to take? The top half or the bottom half? The bottom half goes through the point on the original curve. Good? Question? No. You got it. Gentlemen. You mean that I could divide this by 2 and I could divide these guys by 2? Yeah, you can simplify. I would not take off a point if you got this far. I would not take off a point. Okay. Yeah. Tell me again. Andrew.
I found the domain for part B in a different way. I'm pretty sure it would always work.
Yeah.
I just went to find when, like, under the square root.
Yep. That's okay. So this is a really good question. Really good question. If they had said, don't start with the domain of x equals -6, but start with the domain x equals 6, but start with the domain x equals 2. Well, the inverse function would be this patch. Sorry, this is the patch that we'd be inverting. So the inverse function would start here somewhere and go back that way. So the inverse function would have less domain than it possibly could. Here we had the maximal domain. So the maximal domain of the function that we're taking is the maximal domain of this bigger function. But that's not necessarily always the case.
Yeah.
Okay, does that make sense?
Yeah.
Rohan?
Instead of like, I just completed like the square.
Yeah,
Does that all work?
yeah, yeah. When you complete the square, you'll get exactly the same answer. Peter.
So, just adds the range,
The range, yeah, very good. What's the range of f? It's negative infinity up to 6, because the range of the inverse function is this. Just like the domain of the original function was negative infinity up to 6. Okay, so domains and ranges flip when you interchange x's for y's, which is what the inverse function is. Next. Next. Yeah, one more question. Yes, if the domain of the original function was restricted instead of to 6, let's say it was restricted to 0. Okay, then you want to invert just this much. Well, that means the inverse function will be just this much, and its domain will start at 0 and go down. Even though the square root can take more values. Does that make sense? Going once, going twice. Let's go. Okay, fill in the blanks. I hate these. Sine of 21 pi over 4 sine inverse. Okay, so we have to know. Let me come back. So here's another thing. If there's an annoying problem and you're like, I'm really gonna have to think about this, just move on. Come back to it. Let's come back to it because there's one that I see that I can answer immediately. Log base 35 of what is 1? Log of 1 is always 0. Log of anything of 1, yes, it's 35. Log base anything of 1 is 0. That means b to the 0 is always 1, as long as b is positive. Log of 35 to the first power is 35. Right? Okay. How about this one? This one's easy. For any value of x, if you take 2x, add 98 to it, square that, then take the square root, you're back to where you started. Peter? Yeah, 2x plus 98. Is that right? Yeah. What will we get? It's a good thing we were reviewing this. When you take a number, you square it, and then you take a square root. You take -4 and you square it, you get 16. The square root of 16 is +4. When you square a number, then you take a square root. It's the same as taking its absolute value. You always get the positive value. If the number happened to be negative, you square it. The square root is always the positive square root. Yusuf. Oh, that's a 98, not a 99x. It's asking, fill in the blanks. Simplify it as much as possible. In other words, so it's asking you to simplify what this square root of 2x plus 98 squared is. Whatever, for any value of x, I don't know, it could be positive, it could be negative. When I square it and I take the square root, I'll either get, if it's already positive, I'll just get back to where I started. If it's negative, I'll get the positive value of that. But there's a function called absolute value that does exactly that. Okay. So you have to make sure you put the absolute values. It's not true otherwise. All right. One more easy one. E to the log of 7. X to the 7, exactly. So this is e to the log, natural log of x to the 7. The 7 can come up or down. And e to the log of something is the thing itself, x to the 7. Yeah, if we're taking its log, then x has to be positive, so there's no, otherwise there, so the domain of this thing is x has to be positive, otherwise we can't take its log, and that's so we don't have to do anything, we don't have to worry about that x to the 7. All right, we got these sine inverses and cosine inverses. This is where it gets tricky. Sine stops being 1-to-1 once you get to pi over 2 and negative pi over 2. The second I cross this hump, I'm no longer 1-to-1. I take the same value here as here. Okay, so sine inverse is restricted to this range, negative pi over 2 to pi over 2. So sine inverse is always going to be in this range. So if I said, if you take sine of 21 pi over 4, wherever that is, 21 pi over 4, that's 5 1/4. 21 quarters is 5 pi and a quarter, 5 1/4 pi. I don't know a good way to write this. 5 1/4 pi. 5 1/4 pi. Well, the even number before that is 4 pi. And I'm 1 1/4 pi past that. Okay, so the sine function is doing its thing until it gets to 4 pi, it starts again. And then at pi, so this is going to be, the answer is 5 pi over 4. You guys see that? Sorry, that can't be the answer. 5 pi over 4 is still bigger than pi over 2 and negative pi over 2. Yeah, let's think about this some more. 5 pi over 4 is over here. I need to subtract another 2 pi from that. So I get negative 3 pi over 4. That's over here. Negative 3. No, negative 3 pi over 4 is here. Okay, it's really tricky. Negative 3 pi over 4 is here. Negative 3 pi over 4. I told you I have to think about it. Negative 3 pi over 4 is here. But what do I know about the sine function across this? We got a symmetry here. So wherever it is at negative 3 pi over 4, it's going to be the same at negative pi over 4. God, awful. So the answer is negative pi over 4. You can use the unit circle for this. Yeah, let's try to do it another way. Let's use the unit circle. Okay, so 21 pi over 4 again means we've spun around twice. That's 2 pi, that's 4 pi, and I go another pi and a quarter. That's a good way of doing it. Another pi and a quarter means I'm over here. That's 21 pi over 4. That's 2 pi, 4 pi, another pi, and another quarter pi. Okay. Well, sine inverse of this. What's the sine inverse? Sine inverse is this negative value. But sine only ranges from minus pi over 2 to pi over 2. So where will I have this same negative value? I'm going to have that same negative value right here. That same y value is right here, and that angle is negative pi over 4. So maybe that's an even better way to think about this. Thanks, Stephen. Question?
We like do that as like really take like the value of sine pi over 4 and just use like equal time. Like for example, like sine 2 pi over 4, if you know like negative 2 over 2, negative 2 over 2, then sine inverse negative 2 over 2.
Yeah, you could do that too. That's another good point. Okay, so let's do that as well. So if we're over here so if you know what this is, either by doing it like this or by doing it like that, you know that that value is root 2 over, so this is negative root 2 over 2 is the y coordinate. The y coordinate is negative root 2 over 2. And then you can say, oh, okay, well, I know where that negative root 2 over 2, the inverse sign of that is negative pi over 4. That's yet another way to do it. Yep. We didn't actually have to identify, like if this was a number that we didn't know the sign of off the top of our heads, we would still just be able to figure it out from the symmetry of the sine function. Okay, next. Cosine. Cosine is similar but different because cosine starts at 1, goes down to pi, and that's where we take inverse cosine from. That's where it's 1 to 1. Okay. So 23, let's do it this way, just to change things up. Whoops, didn't mean to mark it. So 23 pi over 3, 21/3 is 7. So I'm going to go 7 times around. 1, 2, 3, 4, 5, 6. Whoops, too much. Yeah, whatever. 7. 7 is the same as just going once to pi. So that's 21/3. And then I'm going to go another third pi and 2/3 pi. So 2/3 pi is over here. Okay. And I want to get the same, the cosine is the x coordinate. And cosine takes its values in the positive domain. So it's going to be the same as this angle here. And if this was a third back, this was pi over 3. If I add one more pi over 3 to 23 pi over 3, I get 24 pi over 3. 24/3 is 8. That's all the way around. So 24 is here. So I want to go 1 pi over 3 back from there, and the same x coordinate would be here at plus pi over 3. So that's where this inverse cosine is going to be, plus pi over 3. Okay. Again, this stuff just takes practice. Now, I don't have as much practice with this as maybe I should, because it took me a minute to figure this out. But you could also figure this out on your own, just from the knowledge of where do we define, the two things you have to know is where do we define the inverse sine function, which we take from -1/2 to 1/2 pi. That's just a decision. We could have said we take it, I don't know, from pi over 2 to 3 pi over 2 or something, right? Human beings said we define the inverse sine function between minus pi over 2 to pi over 2. That's a choice. You got to know what that choice was. Same thing with cosine. You got to know that we chose to go from 0 to pi, to keep it 1 to 1. Beyond that, everything else you have to figure out. Okay, next. How are we doing? All right, we got a half hour left. It's going slow. Starting to go slow. Oh God, I hate these. Biology colony, yada, yada. Population was 40 bacteria at 9 a.m. All right, so at 9 a.m., we got 40 bacteria. In 20 minutes, the bacteria has tripled. So at 9:20, we're at 120, which is triple 40. Okay, the population continues to triple every 20 minutes. Fine. If P is a function that gives the number of bacteria at T hours after 9 a.m. All right, let's write down that function. So P of T, that's the number of times we've tripled in an hour. So we start, so this is after 9 a.m. So T equals 0 is 9 a.m. So we start at 40. And then what's the rate that we grow at? We grow at 3. We triple every 20 minutes, which is a third of an hour. So every third of an hour, we triple. So every hour, sorry, that's not right. That's not right, because when I put T equals a third, I get something way too small. So that can't be right. Maybe it's 3T. Let's see. When T is a third, that's when this is 1, and that's when I get to multiply by 3. And if T is equal to 1, I multiply by 3 and by 3 again and by 3 a third time. So it's 27 times 3 cubed, right? That makes sense to me. That at 9:20 we've tripled, at 9:40 we've tripled again, and at 10 we've tripled 3 times. So that's 3 to the third T. All right, great. We got the equation. All right. P is a function, blah, blah, blah. For what values of T give 120? All right. When is this? So for A, I want to solve this equation. This is equal to 120. So that's 3 to the 3T is equal to, if I divide by, wait a second. Don't I already know 120 is at 920? That's a third. But okay, fine. So 40 divided by 120 divided by 40 is 3. So 3T is equal to 1. So T is equal to a third. But we didn't need the equation to do that. We could have just thought for a second about what 20 minutes is and known that the bacteria was at 120 at 9:20, right? Okay. B, find a function that gives an bacteria, blah, blah, blah. Yeah, okay. So that's exactly the function. This is B. How many hours past 9 a.m. will it take for the bacteria to reach 10,001? Okay, so same exact thing. 40 times 3 to the 3T, which I could write as 27 to the T, but whatever, is equal to 10,001. Well, 3 to the 3t is equal to 10,001 divided by 40. Leave it alone. We don't have calculators, just leave it what it is. If I take log base 3 of both sides, so log base 3 of both sides, I'm running out of room. Let's go over here. If I take log base 3 of this, what do I get? 3t, and I'll take log base 3 of this. Well, it's just whatever it is, log base 3 of 1,000 or 10,001 over 40. And then I divide that by 3. So t is equal to 1/3, which you can think of as the cube root, whatever. I'm not 10,001 over 40. Okay. What's that? Could be log base 27. Yep. I mean, at the end of the day, it's still just an exact answer. So you're right. Yeah, there's a whole bunch of, you could say log of 3 of 10,001 minus log base 3 of 40. And then 1/3 in front. So there's a whole bunch of ways that you can express it, as long as you express it in one of the valid ways. Yusuf.
You do like log base 3, whatever number it is, parentheses divided by 3.
So yep. So if you wanted to take natural logs, for example, that's what you're saying. If you did use the base other than 3.
So 3t equals.
Yes.
I put parentheses around thing, right? And then put divided by 3. No, like the whole thing.
The whole thing, and then divided by 3.
Yeah.
Yep, same thing. Yep. Just 1/3 of this or this thing all divided by 3, all good. Okay, that wasn't so bad in the end. Let's go. We want to solve all of them in 80 minutes. We don't have much time. Fill in the blanks of statement. Okay, notation. Okay, f is a 1-to-1 function with a domain D and range. So I have to draw a picture. Here's my domain D. It's 1-to-1, and here's my range R. Great, that's f. Okay. Then f has an inverse function that satisfies. Okay, f inverse of b is a if and only if f a is equal to b. If I have the point a comma b on my original graph, a comma b, then my inverse graph, whatever it is, something like that, f inverse will have the point, yeah, exactly, b comma a. So if f inverse of b is equal to a, that means f of a is equal to b. Okay, for all a in, well, f only takes values in the domain and b takes values in the range. Okay. Now if you do f inverse rather, and then you do f of x, you'll get back to x. That's exactly what the inverse function is supposed to do. And same thing if you do it in the other order. If you do f inverse, if you do f and then do f inverse, you'll still get x, but what's the domain? F inverse only takes values in the range. F inverse only takes values in the range. F only takes values in the domain. Done. Okay, a couple of pictures and a moment's thought. Next.
You have to specify the range of f.
No, because we are told that there's a region called D, which is the domain of f, and a region called R, which is the range of f. So D and R are those regions as defined. So now I'm going to use those names to answer the question. Okay, suppose f is a 1-to-1 function that takes the value of 194 at 18. What's f inverse of 194? 18. Beauty. Next. The function blah is 1-to-1 in its domain. I'll take your word for it. Find the domain and write the domain using interval notation. All right. What is the domain of this function? The only thing I can't do, I can't divide by 0. Okay, so the domain is x can't be 71. That's not interval notation. Interval notation is negative infinity to 71, union 71 up to infinity. So it's like anybody who wants to can come to the party except 71. You stay. So anything up to 71, and then we're just going to gently skip over 71 and everybody above there. Fine. What's the range of f? What is the range of f? Well, one way to figure out the range of f would be, and by the way, we're going to do it in part C. Let's work out what the inverse function is, and we'll see what the domain of the inverse function is. That'll tell us what the range of f is. Okay, so I got to invert this thing. So instead of y equals 50x plus 13 over x minus 71, whatever it is, I'm going to switch the roles of x and y. So 50y plus 13 over y minus 71. And now I have to solve for y. Okay, let's multiply. I assume y is not 71, so that I can multiply through by this. So now I get x times y minus x times 71 is equal to 50y plus 13. I just multiplied over here, and then I distributed the x's. Okay. I'm trying to solve for y, so let's get all the y's to one side. I have an x times y, and I have a minus 50 times y. And that's equal to 13 plus 71x. So there's my f inverse of x is 71x plus 13 divided by x minus 50. Did I get that right? Anybody get that? Okay, great. Well, what can I put in? So if the function was 1-to-1, the inverse function is 1-to-1. Hard. I got it wrong? Oh, stretcher. Okay. So if the original function, whatever it was, I don't care what it looks like. If it's 1-to-1, well, the inverse function is also 1-to-1. So whatever values it can take in its domain will be the range of the other function. So the range hits all values except 50. How would we know that from looking at this, that the one value you don't hit is 50? By the way, 50 looks like a horizontal asymptote in the positive and the negative direction, right? We got this 50x over x. If x is huge, whether it's positive or negative, that ratio is very close to 50. But we never actually touch 50. Yes, 71 is a vertical asymptote for the original function. 50 is a vertical asymptote for the inverse function, which means 50 is a horizontal asymptote. And we never cross 50. So 50 is not in the range. So the range is negative infinity to 50, union 50 to infinity. Okay. Next. Let's go. Okay, find a function f such that the method makes it possible to evaluate this limit. In other words, just evaluate the limit. Let's evaluate the limit. So we want the limit as x goes to 8. That's the other kind of 8. 8 square root of 9x plus 6 minus root 78 over square root of 7x plus 19 minus 5 root 3. You're going to make me 5 squared is 25 times 3 is 75. Okay, let's see. Do both of these things go to 0? That's my guess. I have something going to 0 on top and on bottom. If x is 8, so I have 8 times 9 is 72 plus 6 is 78. I have 7 times 9 is 56. 56 plus 19 is 75. All right, fine. What are we going to do to fix the numerator? How are we going to figure out this limit? We got to clear these square roots, the annoying square roots. So what are we going to do to fix the numerator? The conjugate, yep. 9x plus 6 plus root 78 over the same thing. I can't change the function. 9x plus 6 plus root 78. That's only going to clear the numerator. What do I clear the denominator with? Yeah, exactly. The bottom conjugate, 7x plus 19 plus root 75 divided by the same thing, root 7x plus 19 plus root 75. Okay, so what function f do I want to stick in on top and bottom to make it possible to evaluate this? Well, this is my function f. Okay, f of x equals the numerator, right? I want to know what do I put on top, and of course I'll also put it on bottom, but this is the function that'll make it possible to evaluate. Okay, now what are we going to get? What's that? That's the answer to part A. Now we have to actually evaluate it. Part B is to evaluate. So this is not going to be that bad. It looks bad, but it's not going to be bad. Great. These two together. All right, let's take them in pieces. These two together is very easy to work out what that is, because it's just 9x plus 6 minus 78. Right? Difference to squares. Same thing over here. if I take this and this together, I also know what that will be. That's going to be 7x plus 19 minus 75. Okay, so that's those two parts. And then I have these two parts left over, which is root 7x plus 19 plus root 75 divided by root 9x plus 6 plus root 78. Okay, let's deal with this. What's going to happen here? It's got to cancel on top and bottom. This is the limit as x goes to 8. I keep writing infinity. Can't help it. I'll tell you guys a joke if I have time. That this reminds me of. Okay, this is 9x minus 72. That's 9 times x minus 8. What about the bottom? 7x plus, oh God, 75 minus 19, 56. 56. So this is 7 times x minus 8. Aha, the x minus 8s cancel. So I get 9/7 times, oh God. Well, this thing just stays as is. Stays as is. So in the end, the limit will be 9/7 times, what am I getting here? This is going to be root 75 and another root 75. So that's 2 root 75, 2 root 75, which I don't care if you're going to change the 75 to a 5 root 3. And then on the bottom, I'm going to get, again, 2 78s. So that's 2 times root 78. All right, well, I guess you could cancel this 2 on top and bottom, whatever. Done. Yusuf. Where did I get what? X minus 8. Here, I'm factoring the numerator. So this is 9x minus 72. And 72, if I pull out a 9, 72 is 9 times 8. Does that make sense? So I factor the numerator to get this. Yeah, exactly. I did 6 minus 78 is negative 72. And I did 19 minus 75 is negative 56. So far, so good? We might be able to get through all of them. Let's go. Let's go. Any questions? Okay, next. Oh, God, tan. All right, hang on. For small positive values of x, we can write this without the absolute value sign. Yes, indeed. If x is small, what is an expression that does not have an absolute value sign? Absolute value of 33x when x is positive? 33x. Okay, great. So it's just tan of 20 over x divided by 33x. Done. Okay, it's not that bad. It looks bad. It's not that bad. To compute the limit as x goes to positive 0 from above, we must multiply by a special 1. In other words, some function on top and bottom. Okay, let's think about this. Let's think about this. Tan of 20x. Tan is sine over cosine. So that's sine of 20x over cosine of 20x. I'm out of room here. Sine of 20x. What do I want to divide sine of 20x by? 20x. So I want to divide this by 20x. But I'm going to multiply by 20x also. So that I'm not doing anything. The tan, I'm still left with a cosine of 20x. Because tan is sine over cos. So that's the tan. I multiply by 20x on top and bottom, and then I have my 33x just hanging out. So divided by 33x. And of course, this x on top and bottom is going to cancel. So what function should we use to build the special 1? We can use 20x. It's kind of a stupid problem in a sense, because we could also use 20, because the x is on top and bottom is going to cancel. We can manipulate that. So there's not really a real answer. I hope I don't have a problem like this on the midterm. You could say f is 20x, or you could also say f is 20, or you could just say you can figure out the limit without multiplying by a special 1. But presumably what it's looking for is this. Okay, that's really the I would argue against a problem like this. Okay, it's a little ambiguous. All right, compute the limit if possible. Is it possible? The x on top and bottom is going to cancel. I get 20 over 33. The cosine is going to 1, and sine of 20x over 20x is going to 1. Beautiful. So I know what it is. It's just 20 over 33. Be sure to provide a mathematical justification for your conclusion. Okay, so let's be sure to do that. I don't have room here to do it, but this goes to 1. This ratio goes to, or actually is equal to 20 over 33 for all values of x not equal to 0. And cosine goes to 1. Okay. And so if this is getting closer and closer to 1, this is getting closer and closer to 1, that's getting closer and closer to 20/33, then that's the limit. Okay. Sorry? No? Okay. If x is negative with absolute value of x small, can we rewrite g without using the absolute value sign? Yes, of course. If it's negative, then absolute value of 33x is negative. Yeah. So what is the expression? It's tan of 20x divided by negative 33x. That's it. To compute g, we must, are you kidding me? It's the same function. I mean, whatever. Yeah, okay. F is 20x or something. It's still the same 20x on top and bottom, regardless of whether it's positive or negative. Okay, compute the limit if possible. What's the limit going to be? Negative 20/33. Because all we did is we changed the function by a minus sign. Whether we come in from the right or the left doesn't change the value of sine theta over theta. That really does have a limit whether you're coming from above or below. So this is negative 20/33. And the mathematical justification is the same as before. Same. Okay. Compute the limit as g of g as x goes to 0 if possible. Is it possible? No. The left limit and the right limit go to different numbers. So does not exist. Limit from 0 from above does not equal the limit as x goes to 0 from below. Okay. Okay. Could you define g of 0 in a way that extends this to be continuous at x equals 0? No. Why not? Raga. Yeah. For a continuous extension to exist, I guess I left all this room to do all this work, but okay. To exist, and instead I tried to sneak it in here. To exist, how do you spell exist? Oh my God. Exist, there we go. For a continuous extension to exist, you need the limit as x goes to 0 to exist. But it doesn't. Sorry? Yes. Provide the mathematical justification. For a continuous extension to exist, you need the limit to exist. It doesn't. It doesn't. So no. So no. The answer is no. Okay. Next. 10 minutes, 4 problems. Let's go. If the limit exists, computed. Show all the work. Okay. Fine. What are we going to do? We got a sign on top. That likes to go with an x, but we have a cos, 1 minus cos. What do you do with a 1 minus cos? It's going, we want to multiply it by 1 plus cos. A 1 minus cos, we want to multiply by 1 plus cos. So if I have x sine of 5x over 1 minus cosine of 6x, well, one thing I'm going to want is a 5x, is an extra 5x on top and bottom. If you like to do that kind of thing, again, you don't have to. That's going to help me with the with this. What about the cosine? I'll multiply by a 1 plus cosine of 6x and a 1 plus cosine of 6x. By the way, make sure that we do indeed have a limit as x goes to 0 and not some other place where you can just plug in the value. Yes, it's at 0 where we have problems. 1 minus, so let's put these together. So sine of 5x over 5x, that's going to 1. 1 plus cosine and 1 minus cosine turns into 1 minus cosine squared. That's why I wanted to do that, because a 1 minus cosine squared is a sine squared of 6x. Okay. And now, what do I have left over? I have this 5x left over. 5x is left over. And I also have a 1 plus cosine of 6x left over. Okay. So these two together made this denominator. The 5x is left over. The 1 plus cosine of 6x is left over. And there's an extra x, thank you. And there's an extra x in front that we have to make sure we don't drop. We would notice that we dropped it immediately because something was about to go wrong. Sine squared of 6x, I can pair with a 6x squared. But if I'm multiplying it there, I have to multiply it here, which is a 36x squared. Okay, this ratio goes to 1 because it's sine of 6x over 6x, and another one, sine of 6x over 6x. Both of those together, both of those individually go to 1. And then I have this. What's happening to 1 plus cosine of 6x? That's going to 2. These are going to 1. This is going to 1. And so what am I getting? 5 times 2 is 10, 10 over 36, which I could simplify as 5 over 18. All right, that's one. This one I think you guys could do. We don't need to go over this one in the interest of time. How would you do this one? I would set t equal to 1 over x, so that this is the limit as t goes to 0. Limit as t goes to 0 from above. Maybe that would make a difference, maybe not, right? Because as x gets infinitely large, t is getting closer and closer to 0, but it's staying above 0 the whole time. And then I have an e to the t and a cosine of 4t. Great. What's happening to e to the t at 0? This is going to 1. What about cosine at 0? That's 1. Oh, beautiful. 1 times 1 is 1. Next. Question. Oh, 3t. Thank you. Thank you. 3t. Not t, but 3t. I dropped the 3, but t is going to 0. So 3t still goes to 0. So e to the 0. Okay. Great. Okay. Next. Suppose we have functions f and g with these properties. The domain is everything. The range is everything. F of -4, whatever the value of f is, it's larger than the value of g. But at -1, whatever the value of f is, has now gone below the value of g. So that's f, that's g. X equals 2 is the only solution. So x equals 2. X equals 2 is the only solution where f is equal to g. Uh-oh, something wrong with what I drew. I'm saying they cross down here, but they're saying the only solution to this equation is outside of the interval -4 to -1. Your spidey sense should be going off. Determine if the following statements are true or false. Either f or g is not continuous. If both f and g were continuous, they would have to cross. They don't cross because the only place where they agree is out here. So either f or g is not continuous. That's true. One of them must not be continuous. We have to jump over. One has to jump over the other because they're defined everywhere. They're defined. Their domain is everything. So one has to jump over the other so to make sure that they don't cross. Okay. The limit as x goes to 2 of f of x minus g of x is 0. True? Their values agree at 2, but there's nothing stopping one from coming like this and like that, or one having a limit to here and one having a limit to here, and then jumping to 2. We never assumed f and g were continuous. Okay, the values agree. The limits we have no control unless we know continuity, and we were never told the functions were continuous. Okay, don't let them get you. False. Limits not known to agree. Limits not known to agree with the value. In other words, we don't know that the functions are continuous at 2. Okay. F of c minus g of c is equal to 0 for some c in this interval. We don't know that they're continuous. Okay. So false. False. It could be not continuous. Could be not continuous. All right. Let's go. Oh, it wants to give examples of functions. So draw your favorite thing that goes and jumps over. You know, this is G, this is F, this is G, right? It starts out above, ends up below, and it jumped over. Whatever. I'm rushing because I want to get to all the problems. If F and G satisfy this and this, and define H to be this. Oh God. All right. What's going on? Where does this go as X goes to 3? I've got 9 minus 3 plus 3, so I got 9. This is going to 9. Where is this going at X as X approaches 3? I've got 2 times 9, 18 plus 9 is 27, minus 7 is 20. I hope someone's checking this. I'm doing it very quickly in my head. How about this? I got 1, 2, 3, so that's going to 3. At 1, and at 1, this is approaching 2 plus 5 plus 7 is 14. Okay, so compute the limit of as X goes to 3 of F. No, it's going to 2 different values. Does not exist, going to 2 different values. How about of G? Does not exist, going to 2 different values. I have a feeling I know what's coming. H is F minus G, and the G has been slid over so that when X goes to 3, X minus 2 goes to 1. And F minus G, F is going to 9, minus 3. 9 minus 3 is 6. And 20 minus 14 is also 6. So the amount that F and G jump there, H just perfectly off balances so that the limit does exist. So the limit does exist. And F is going to 9 minus 3 is 6. Compute this limit. The limit is equal to 6. I realize I'm doing that very quickly. You'll have to look it over at home. Is it possible to define H of 3 in a way that it's continuous at 3? Yes. Set H of 3 equal to 6, and then it'll be continuous because the limits exist in either direction. All right, last one. Whoever has to go ahead. I'm gonna just keep. We have last 2 left. Make this function and this function. Okay, what's the domain of F? I can't divide by 0, so X is not equal to 1. I also can't take the square roots of negatives. This should scream something at you. The square root of 49 minus 7 is going to be a circle of radius 7 around the origin. So X has to be less than 7 in absolute value. And so the interval notation is minus infinity up to, sorry, not minus infinity, minus 7. Minus 7 up to 1, union 1 up to 7. Okay. How about this? The domain. Thank you very much. I certainly want to include the closed brackets. There's no problem with square roots of 0. Thank you. Another reason that you should always go over your problems. Interval notation to describe the domain of G. Now I need this to be greater than 7. I need the square root of x squared plus x squared minus 49 to exist. So I need x to be greater than 7, so I can get outside of 49 and negative 49. So absolute value of x has to be greater than or equal to 7. I still have a problem at 1, but 1 is no longer a concern. 1 is inside the region that's removed. So it's minus infinity up to negative 7, close bracket, union 7 out to infinity. Okay. What is a horizontal asymptote of y equals f? F's not even defined. You can't get a horizontal asymptote without going out to infinity. So none. None. How about the horizontal asymptotes of G? If x is huge, I get roughly x on top and 9x on bottom. So that's a 9th. So the equation is y equals 1/9. What about if x is huge negative? If x is huge negative, that square still makes it positive. So this is a positive number. This is a negative number. So my 2 horizontal asymptotes are a 9th and negative a 9th. X still can't equal 1, but this is asking about the limit as x goes to minus infinity and plus infinity, horizontal asymptotes of G. So this is one piece of the domain, and here's the other piece of the domain for G. But that's not x equals 1/9, that's y equals 1/9. So what I'm saying is whatever G looks like, here's negative 7. G doesn't even exist unless you're below negative 7. And what it does eventually is it starts looking like negative 1/9 down here, whatever it's doing, and then it starts looking like negative 1/9. And 7 above 7, that's a positive 1/9. Of course, here's negative 1/9. So it's negative 1/9 over there, and then it's positive 1/9 over here. That's what G looks like. Okay. What about vertical asymptotes for F? Vertical asymptote of F is where we're dividing by 0. So this is x equals 1 is a vertical asymptote. How about for G? Again, x equals 1. No, G doesn't exist unless we're big outside of -7, so none. Okay, the oblique asymptotes. All right. We hadn't really discussed, we ran out of time to discuss oblique asymptotes. Let me save this for the very end to see how many of you are still here. And we're going to come back to F and G. G and G. First of all, an oblique asymptote, instead of having a horizontal asymptote, is like a line that the thing is approaching. So an oblique asymptote can only exist if you are going out to infinity, and F doesn't go out to infinity. The domain of F is restricted to -7, so this automatically we'll have none. But part H we're going to come back to in a second. Let's do number 22. Okay, compute the limit as f goes to -3 from below. So the limit will be a times -3 plus b, whatever a and b are. Right? How about from above? From above, I'm going to get -3. That's 9 times 4 is 36. 36 plus 5 is 45. So this goes to 45. Right? If f is to be continuous, what expression must b equal? If f is to be continuous, when x goes to -3, I get -3a plus b. There's something wrong with this problem. I think the a shouldn't be here. If the a wasn't there, then we would get -3, and then we would say that b must be equal to +3. There's a mistake in the problem. It's not well defined because I have two parameters that need to be chosen to make it continuous. You see what's going on? So there's a typo. If x is not continuous, what kind of discontinuity will it have at -3? It'll have a discontinuity where it has a limit from the left and it has a limit from the right, but the two limits don't agree. So a jump discontinuity. Jump discontinuity. Okay, let's spend a minute on oblique asymptotes, and then we got to go. Oblique asymptotes. Okay, so there's nothing to say for F. For G, well, actually we have horizontal asymptotes, which means we can't also have oblique asymptotes. But if you have a function like 3x squared plus 17 divided by x plus 5, okay, so that eventually will start looking like 3x. But you can get more information than just 3x. So it'll have a slope of 3x, but where? Over here or over here? Like, how do we figure out what the shift is? So to work out an oblique asymptote, you can do long polynomial division. So let's remember long polynomial division for a second. If I take 3x squared plus 0x plus 17 and I divide it by x plus 5, how would I do that? This is not hard. It's just like regular division, regular long division. So if I need to get 3x exactly, if I want to get 3x squared, I'll take 3x, and I'm keeping everything aligned. The x's go here, the x squared go here, the x to the zeros go here. So 3x, if I multiply that, that's 3x squared plus 15x. I've taken that into account, so let's subtract these off. This exactly cancels, and I get -15x. The plus 17 comes down, plus 17. And now what do I multiply this by to get rid of the leading term? Yeah, -15. So -15. So now when I multiply this, I get -15x minus 15 times 5, 75. 75. I've taken that much into account, so I'll negate that, and I'll add them together, and I get 75 plus 17, 80, 92. 92. So there's a remainder, so plus 92 over x plus 5. This is the oblique line. So 3x minus 15. I had a -75. And then I changed the sign of both of them because that's how much I've taken into account already. I think I got that right. I could have gotten any of these things wrong, so please check at home. But I think that's the oblique asymptote for For G, that's the entire 22 problems in roughly 80 minutes. You will have many fewer problems, and I hope you will be able to get through them in